Welcome to our new video series. We're testing out newer approaches to explain AI, and we need your feedback. Is it too easy? Too complex? Let us know in the comments. We love hearing your ideas for future videos as well. Please share, like, and subscribe if you find this useful. Today, we are stepping into the agent's kitchen. The promise of generative AI is huge. Autonomous agents that can solve complex problems, run operations, and act as personalized assistants. But the reality often falls short. Many agents are flaky, unpredictable, and prone to failure. We believe the key to reliable AI isn't in developing the next huge foundational model, but in mastering the process of LLM engineering for modern agents. Think of it as following a rigorous recipe. This presentation will cover the critical, systematic approaches necessary to move beyond simple prompting and build agents that actually work in enterprise environments. We will explore how to manage the agent's context state as a unified system, ensuring success and reliability in every task. This mastery is what transforms a simple prompt into an intelligent system capable of complex, multi-step execution. Look at these two pictures. On the left, we have the broken agent. Chaos reigns. Ingredients are everywhere, smoke fills the room, and the resulting dish is unpredictable. On the right, we have the brilliant agent. It's clean, organized, systematic, and producing high-quality results consistently. Both of these kitchens use the same high-end equipment, the powerful LLM models and the sophisticated agent architectures. Yet, their outputs are worlds apart. The difference, however, isn't the model or the architecture. It's the recipe. It is the instructions and the meticulous process they follow. We have reached a point where model size is no longer the bottleneck. Effective guidance is. The critical missing ingredient is effective LLM engineering. This isn't just about writing a good prompt anymore. That era is over. This craft has evolved into what we call context engineering. This is the strategic management of the entire context state as a unified system. That includes the initial instructions, the available tools, the memory of past actions, and the history of the conversation. When you master context engineering, you unlock the secret to building agents that are reliable, robust, and truly brilliant. An AI agent is truly a kitchen, and how you choose to run it fundamentally determines the result. Let's look at 4 crucial distinctions that separate a chaotic agent from a high-performing one. First, the problem of vague instructions leading to chaos. Telling an agent, "make something good," is a weak prompt. It gives the agent zero structure and no defined success metrics, resulting in unpredictable and often useless output. Instead, we need a clear mandate leading to direction. This mandate is codified in a strong system prompt. You define the role, the constraints, and the goals. For example, you are an Italian chef, stay on budget, and use these specific tools. This firm's starting point acts as the agent's constitution. Second, we move from randomness to quality through a structured workflow. Instead of just asking for the final product, we enforce task decomposition. Plan, then prep, then cook, then check. Breaking down complex problems prevents errors from compounding and ensures every step is executed correctly and deliberately. Third, and finally, the path to mastery requires constant learning. A brilliant agent doesn't just complete a task, it asks, what worked? What didn't? This is self-critique and reflection. It is the vital feedback loop that continuously drives improvement and adaptation, ensuring the agent gets better with every dish it prepares. If you want a brilliant agent, you must start with a clear, unambiguous mandate that defines success. This mandate is known as the system prompt, and it is the foundational instruction that governs every aspect of the agent's behavior. A strong system prompt is not vague. It is a precise document that defines the agent's entire world. We recommend framing your system prompt by answering 5 key questions, much like a meticulous recipe card. First, role or identity. Who are you? For example, a meticulous financial analyst. This sets the tone, scope, and voice. Second, objectives. What is your primary goal? To provide objective analysis of market trends. This defines the purpose and the desired outcome. Third, constraints. What are the non-negotiable rules? You must cite all sources and never state opinions as facts. These rules prevent harmful or undesirable behaviors and enforce ethical boundaries. Fourth, tools. What resources can you use? Have access to a web search tool and a database query tool. Listing specific tools enables action and allows the model to correctly reason about when to call those external functions. And fifth, output format or final plating. What must the finished product look like? Your final output must be a markdown report with a summary, key findings, and a source data table. Defining the structure ensures immediate usability and reduces the agent's freedom to generate unstructured text. By rigorously defining these 5 elements, you eliminate ambiguity and significantly boost reliability. When crafting that system prompt, we need to think carefully about prompt altitude. The effectiveness of your prompt depends on finding the sweet spot between being too vague and being too specific. If you're too specific, the system becomes brittle. If you're too vague, it becomes unreliable. Let's examine the extremes. On one end, we have too low or overly specific prompts, which we call brittle. This is micromanaging the agent with hard-coded logic, such as saying, if the user says analyze, you must call tool A, then tool B, then tool C. This approach breaks easily because real-world tasks rarely follow such a rigid script. The agent loses its ability to reason and adapt to slight changes in user input. On the other end, too high or vague prompts. These are useless platitudes, like be helpful and smart. The agent gains no real guidance from these instructions, leading to random and unpredictable results. The goal is the right altitude, which provides guidance. Here, you provide a clear objective and guiding principles, empowering the agent to reason and adapt to unforeseen circumstances. For example, your goal is to compare market positions. Start by researching competitors, then synthesize the data into a strategic overview. This provides a clear high-level plan and direction without enforcing rigid, hard-coded steps, allowing the model to use its reasoning power effectively. Your context window is arguably the most precious resource in the agent's kitchen. It is your countertop. And like any small countertop, if you pile too much stuff onto it, you can't work effectively. The challenge in 2025 isn't just writing one good prompt, it's context engineering, which is the strategic management of this entire limited context window. Throwing everything in, a massive system prompt, definitions for every tool the agent owns, the full unedited chat history, and irrelevant retrieved data, simply overwhelms the model, leading to confusion and dramatically degraded performance. This leads to what we call focus loss. The strategic approach is to keep the countertop clean and focused by implementing 4 core principles. First, prioritize. Only include what is absolutely essential for the current specific step of the task. If you're drafting, you don't need the database query tool definition. Second, dynamically load tools. Don't show every tool definition simultaneously. Provide definitions only for the tools that are highly relevant to the task the agent is currently executing. Third, summarize history. Condense past turns. Instead of including the full transcript of a 50-turn conversation, keep only the key insights, decisions made, and unresolved questions. And fourth, retrieve precisely. When fetching external data via RAG, fetch only the most relevant, high-quality chunks of external data, avoiding excessive noise that distracts the agent from its main objective. Never ask the agent to cook a complex dish from scratch in one single step. LLMs are notoriously terrible at multi-step reasoning when faced with a single, massive request. If you ask a single agent turn to build a whole application or write an entire book, it will likely fail or make critical early mistakes. The solution is task decomposition, breaking a complex problem into a sequence of simpler, easily solvable sub-problems. Think of this as the chef's mise en place, or preparation, the organized setup that ensures a smooth, predictable, and successful execution of a complex dish like beef Wellington. By breaking down the task, you guarantee that the agent focuses on one manageable objective at a time, minimizing the chance of accumulating errors. We rely on 3 primary methods for implementing decomposition. First, LLM-driven. Ask the LLM itself to create the plan first. This is highly flexible and excellent for novel tasks that you haven't seen before, enabling dynamic adaptation. Second, programmatic. Define the steps yourself in code. This is predictable, robust, and perfect for recurring, well-defined tasks where steps must be followed exactly. Third, hierarchical. This is the most scalable approach for very complex, enterprise-level problems. You break big tasks into smaller tasks, which are then broken down further into atomic steps, ensuring clarity, accountability, and quality control at every level of execution. No great chef serves a dish without tasting it first. Likewise, an LLM's first attempt at a solution is rarely its best. To achieve high quality and high accuracy, we rely on the self-critique loop. This essential mechanism forces the agent to review and significantly improve its own work before presenting the final output to the user. This process is essential for high-stakes tasks where accuracy and quality are paramount, such as financial reporting or medical diagnostics. The loop consists of three main stages, visualized here. Step 1 is generate. The agent produces an initial, often rough solution to the problem using its tools and knowledge. Step 2 is critique. The agent, or often a separate, specialized critic agent, evaluates the initial solution rigorously against a predefined set of standards, principles, or checklists provided in the system prompt. For instance, the critique might check for citation compliance, factual accuracy, or adherence to formatting rules. Step 3 is refine. Based on the feedback generated during the critique, the agent revises and improves the solution, generating a new and higher quality output. This revision process continues until the solution meets the required quality standard. A crucial engineering note here is the use of an internal scratchpad, which can be used for this messy thinking process and critique notes, keeping the final, clean output pristine and easy for the user to consume. We can elevate critique from a simple, single step to a robust, continuous learning system that drives long-term agent improvement. Let's look at two advanced patterns for institutionalizing quality in production environments. First, the dual model approach. For high-stakes production systems, we often find it beneficial to use two separate models. A generator model creates the primary output or solution. Then, a specialized critic model rigorously evaluates that output. This separation of duties is incredibly effective because the critic model is optimized purely for quality assurance and verification, not for generation. This division is like a head chef getting a second, objective opinion from a trusted sous chef who is known for their unwavering attention to detail and rigorous standards. This leads to far more objective and reliable critiques. Second, the reflection pattern. This is the ultimate critique loop that enables agents to improve autonomously over time. After completing a task, the agent doesn't just stop. It generates a meaningful, semantic reflection on what it learned, what went wrong, and crucially, what it should do differently next time the task is encountered. This reflection is then stored in the agent's long-term memory and accessed before starting similar future tasks. This iterative learning process is exactly how a brilliant human chef perfects a signature recipe over years of practice and self-assessment. The agent truly learns from its failures and improves its performance, leading to self-mastery. Here is a painful truth about all agentic systems. Per-step accuracy degrades severely over long chains of reasoning. As the number of execution steps increases, the overall reliability of the result plummets. This means if you're aiming for a flawless multi-course meal, an early error can poison all subsequent steps, leading to a meal that gets worse with each course. This failure happens due to several related phenomena that we must engineer against. The first and most insidious is error accumulation. Even if each step is 98% accurate, small mistakes compound exponentially over time. A small factual error in step 1 becomes a massive strategic mistake in step 10. Second, context degradation. The original high-level goal gets buried deep down in a long message history. As the conversation progresses, the context window fills up with transient details, pushing the essential initial instructions out of view. Third, focus loss. This is a direct consequence of context degradation, where the agent simply loses track of the high-level objective or the core principles defined in the initial system prompt. Serving a flawless multi-course meal or completing a complex chain of tasks therefore requires implementing systematic checks and balances designed specifically to maintain quality and refresh the agent's focus from start to finish. Since errors accumulate and context degrades over time, we must implement systematic checks and balances throughout the workflow to ensure consistency and maintain quality. We have 4 core techniques here. First, intermediate verification or tasting each component. Don't wait until the end to check the result. After each major step, like fetching data, summarizing it, or generating a draft, verify the intermediate output is correct and compliant with the prompt before proceeding to the next step. This catches errors early before they compound and saves significant computational cost. Second, the explicit scratchpad, or keeping clear notes. The agent should maintain an internal, structured scratchpad of critical facts learned, decisions made, and key calculations. This mechanism keeps the most vital context fresh and prevents the agent from forgetting essential information that might otherwise be pushed out of the context window by the conversation history. Third, active context management, which we call cleaning your station. This is proactively summarizing, pruning, and prioritizing the context window. We manage the limited space to keep the agent focused only on what is currently relevant to the task at hand. Finally, tool grouping or organizing your spices. If your agent has 100 tools, never expose them all at once. Group tools logically, for instance, data analysis tools or content creation tools, and only expose the relevant group for the specific task or step the agent is working on. This reduces confusion and minimizes the chance of hallucinated tool calls. To build enterprise-grade, reliable agents, we must master a few key architectural patterns. These patterns represent proven recipes for success in different use cases and are the foundation of modern agent design. First, le classique, task-oriented agents with bounded autonomy. These agents are designed for executing well-defined workflows with extreme precision. They are excellent for structured tasks like data validation or standardized reporting, where the steps are fixed and little creative freedom is required. Second, le critique, reflective agents with built-in quality gates. These agents leverage the self-critique loop we discussed earlier for content generation and analysis, where output quality is non-negotiable. They ensure high-fidelity results before delivery by rigorously testing their own output. Third, la Brigade, collaborative multi-agent systems. This powerful pattern uses a team of specialized agents, like a researcher, a strategist, and a writer, working in concert. Each agent is optimized for a single role, increasing efficiency and quality across the entire workflow by dividing the complexity. Fourth, L-evolution, self-improving agents with continuous monitoring. These agents track their own performance metrics in real time and are engineered to trigger retraining or adaptation when they detect any degradation in performance, ensuring they remain reliable over time without human intervention. Finally, la bibliothèque, RAG agents with retrieval and reflection. These are advanced RAG systems where the agent not only retrieves information from a knowledge base, but crucially, it reasons about that information's quality, source, and relevance before deciding to use it in the final output, minimizing hallucination. Even the best chefs face unexpected issues in the kitchen. In agent engineering, we have specific nightmares that often arise, and we must engineer our way out of them with disciplined architecture. Our first nightmare is inconsistent message roles. This occurs when the agent confuses instructions given in the system prompt with data returned from a tool, leading to unpredictable behavior. The fix: maintain strict separation between the system, user, and tool messages in your architecture. Each type of message must be clearly delineated and processed according to its role. Our second nightmare is overwhelming context. This is when the agent drowns in irrelevant information from long history logs or noisy retrieved documents, leading to focus loss. The fix: implement aggressive context budgeting and summarization, ensuring only high-signal information remains accessible to the model at any given time. Moving to the right, we face runaway loops. The agent gets stuck repeating the same step endlessly, burning tokens and never finishing the task. The fix: define clear termination criteria and set hard limits on the system, such as a maximum number of steps or a token budget for a single interaction, forcing the agent to stop or report failure. Our final common nightmare is hallucinated tool results. The agent imagines what a tool would say or the output it wants from a tool, instead of actually executing the call and waiting for the real output. The fix: validate all tool calls in your architecture and ensure the agent's reasoning is based only on actual verified tool outputs, not speculation or fictional data. Ultimately, this journey, moving from a novice prompt writer to a master chef or a master LLM engineer, requires embracing 5 core engineering principles. The first principle is clarity beats cleverness. Simple, explicit instructions are always better than complex, ambiguous ones. Do not rely on emergent properties if you can achieve the goal through direct, unambiguous instruction. Second, structure enables reasoning. Decomposition and explicit workflows are not constraints that limit the model. They are essential scaffolds that facilitate better, deeper, and more reliable thinking, especially over long task chains. Third, verification is non-negotiable. This is the maxim of trust but verify. You must always build in checks, critiques, and validation steps to assure quality at every stage of execution, preventing early errors from compounding. Fourth, context is king. Your primary job as an agent architect is to be the master of the context window. Manage that resource aggressively, prioritizing relevance and freshness, ensuring the agent always focuses on the most critical information. Finally, measure everything. You cannot improve what you do not measure. Implement comprehensive logging to track every action, measure success rates, analyze step failures, and proactively learn from those inevitable failures to continually enhance your agent's performance. It's not about writing prompts. It's about designing resilient, reliable systems. Before we wrap up, here is your to-go box. A list of foundational papers and resources for continuing your journey in LLM and context engineering. In foundational papers, we highly recommend reading up on the 3 pillars of modern LLM reasoning: chain of thought prompting, which introduce step-by-step reasoning; tree of thoughts, which enables exploration of multiple possible paths; and reflection, which codified the self-improvement loop we discussed today. For framework resources, Anthropic's detailed work on effective context engineering is mandatory reading for anyone building production systems. We also recommend learnprompting.org for advanced decomposition techniques and practical implementation guides. Finally, keep an eye on recent insights, particularly in the realm of long task chains. Papers focused on million-step, zero-error execution highlight the cutting edge of what is possible when these engineering principles are applied rigorously. Thank you for joining us in the Agent's Kitchen. We hope these recipes provide the structure you need to build your next generation of reliable, brilliant AI agents. Please remember to share your feedback in the comments and subscribe for future videos on advanced AI engineering and agent design.